Oh, we're live. All right, we checked the procedure. We got the webcam ready. We're running the test. We're live. Here we go. So you can see our rotational rate is significantly faster for this piece of software. One thing that came up in the last section, somebody asked what happens if we accidentally run the demo software for the sample that's installed, and that could be very problematic because we have a really fast ramp. But you should be able to see that in a couple places. So right here, the name is obviously incorrect. It doesn't have 20 or 400. Also, we don't have any measurement of the shear strength. So if you look down in the lower right-hand corner, you don't see 4 numbers. That means you have the wrong file, so you should stop immediately.
So plastic is clearly inconvenient.
Yeah, it's not straight. So that's not an optical distortion or anything. That's really what's happening. So if you guys want to come up and look at it, you totally can. Don't get too close unless you have safety glasses.
That's called writing, which is happening when you have like a cable like this. You keep applying torsion and torsion. Eventually, you're going to have something that looks like that. You're going to start twisting over itself. Doing something like this. And get this weird shape. And if you keep going, it's going to do something like this. That happens faster when you apply torsion also, twisting and torsion. So this one will lock the moving in the back. So it's not moving like that. Otherwise, it would take much longer to see that behavior. And that will only, it requires a lot of torsion, like right now at 500 degrees. So it's never going to happen with a metal, like a metal tube, it will break before. But in the plastic, it could take background deformation. It's an instability. It's basically a vacuum when you apply to a ruler and it bends to the side. But in this case, the loading is much more complicated, so that's what usually people look at this when they deploy underwater cables, for example, for the internet or for power. You need to be careful with that.
There was like a 7 decrease in torque. Does it stop? Does it know that?
I think that's how this software is set up, is when there's a huge decrease. Now, I don't know what the limits are here. That would probably indicate either slipping or braking. I don't think the machine's smart enough to be able to distinguish the two. I don't know how you would distinguish the two from a software standpoint, but
But then it would stop spinning.
it would stop spinning, yeah.
They usually come with a default thing that if the rate of change in load is too high, because something breaks or something, the machine will, you can always override it, but the default, like something, the load changes very fast, it will shut everything down. Because it assumes there is something weird.
Okay. I'm not sure if I have that. I would bet a.
So I switched the view because on the other view on the webcam, you see well, but here you can see we have a blue indicator line and I guess a brownish darker indicator line to kind of show you how much it's really twisted. And our angle is about 1100 degrees. So several rotations. Sorry, am I in the way? Nice. Is this how candy canes are made? Yes, this is how candy canes are. No, I don't know how a candy cane is made. I don't. I guess it could be, right? Do you know how candy canes are made? I have no idea, but maybe they have a how it's made on that. If I had to guess, it would just be that they have the stuff and then they twist it a little bit, right? I don't know how they get the cane shape. That's where the elves came in. I would have it.
They actually do put it. I mean, it's not.
Sometimes, well, I don't know.
And I mean,
Live streaming too? Is it like in stereo? We've got one live stream and then this other live stream? That was crazy.
a competing channel.
We would get a letter from YouTube if that's what we were doing. So if you want to see the bigger torsion machine, that's actually downstairs. It's too big to fit on a cart like this. It's too heavy. So you can go take a look at it. It's not quite as fancy. For the new building, so for your senior project, maybe you'll have some kind of materials testing involved in that, perhaps. We're not going to be taking this machine, most likely, but we've actually just purchased, I think it's a $350,000 or $400,000 machine that can do tension at the same time as torsion, and it's hydraulics. You can do really dynamic tests. So that's, I guess, a little plug for the new building, which will be there in, I think, 7 months. So that's cool. So when you come back as seniors, you can get exposure to that machine if it pertains to your senior project. Yeah, this is interesting. Yes. I don't know the number on those ones, but they're on the order of, I think, $2,000 or $3,000. Yeah, they're fairly expensive. Yeah, they are pretty new. We're getting newer ones for the new building, so that's another plug for the new building.
Way better ones than we do.
Yeah. Oh, really?
Yeah, they're insanely nice.
Well, that makes sense,
Yeah, I
right?
know, yeah.
Well, you guys will be getting exposure to the oscilloscopes downstairs next semester, right? Spring for 3,300.
Well, LA.
Tune in to the YouTube real quick. You'll be able to see it. So that was it.